Hi, my name is Callie Collins, and for my presentation on climate change, I chose to look at the effects of desertification and how it plays a role within climate change. Desertification is a misleading word. It does not just mean that a non-desert land is simply turning into desert. Instead, the definition means that land degradation is occurring within the dryland ecosystems. The drylands are composed of arid, less than 250 millimeters of precipitation a year, environments, semi-arid, 250 to 500 millimeters of precipitation a year, environments, and subhuman uh, environments, which include the biomes of grasslands, savannas, and Mediterranean climate. Arid is the closest to desert-like conditions, and without factoring in any other factors into these climate conditions, this land is already vulnerable to land degradation due to water scarcity, droughts, flooding, and soil erosion that comes with being a dry land climate. There are other factors besides strictly just climate that affects drylands and increases desertifications. These are all human causes, though, and the biggest one is unsustainable land management that is increasingly furthered with climate change. Unsustainable land management includes overgrazing, which strips vegetation from soil, leading to soil erosion, which makes it harder to increase vegetation within the drylands, overcultivation, an increase in non-sustainable farming using poor land for agriculture, desertification, poor water management with poorly planned irrigation systems that can drop the water table and increase the aridity of the soil, which can lead to further soil erosion. And finally, wildfires. Some of these may be natural, some may be man-made induced. This further strips vegetation and increases dryness, which can lead to more land degradation. With these conditions of unsustainable land management are further influenced by the climate. Desertification rapidly increases. A general rule of thumb is that as climate change continues, dry areas will get drier and wet areas will get wetter. The problem is that more of the global population lives in arid regions versus the humid regions. Overall, in 2013, drought has increased globally by 1%, which seems small, but think of the drastic increase in wildfires in 2020 had one of the driest years on record. With a global increase of temperature and drought, these conditions push for an increase of desertification. The ICPP predicts that by increasing temperatures past 2 degrees Celsius will increase desertification faster versus staying in the temperature range increase from anywhere from 0.5 to 2 degrees Celsius. This range is the goal. It is important to note that the large number of human occupation of drylands and there's a projected increase of population specifically within arid environments. Currently, Africa has experienced an increase in aridity, making many environments show signs of major land degradation and drought compared to just a couple years ago. By 2100, dryness is projected to rise by 5% globally, further indicating a decrease in biomes that are above subhuman and can have detrimental impacts on agriculture and biodiversity. The graph on the left indicates in graph B the effect of climate has on the vegetation in arid regions. Overall, there's rather a decrease in vegetation coverage, while graph C indicates land management use. Overall, the vegetation decreases in areas of poor land use, and the gray mass of the graphs are those that are not the drylands. And the top graph A shows an increase of CO2 fertilization within the drylands. Looking deeper at the current effects of desertification is the time period from 1950 to 1990s. A total area of 2 billion hectares of land went through desertification. That is 15.3 of drylands on Earth's surface. Desertification is occurring at a rapid rate currently today, with 12 million hectares are lost every year to desertification. Within those 12 million hectometers, about 20 billion tons of grain could grow on the land that is lost to desertification processes. And just to put that in perspective, that is 3 times the amount of land as Switzerland or half of the UK by area. The map on the right shows a giant red dot. That dot is how much land is lost in a year in perspective globally. This amount of land lost is likely to increase as temperatures and dryness of Earth increases. There is unfortunately also a 20% decrease in biodiversity within arid regions that experience desertification. So, why is desertification bad for the human population? Within arid or dryland environments, about 1/3 of the human population lives within these climate conditions. That is 3 billion peoples. And these current environments must also sustain 50% of the livestock population and 44% of the world's cultivated systems. With this decrease of cultivated land comes an increase of food insecurity, a decrease on crop yield, decrease in livestock yield. Globally, as desertification increases, food and human resources decrease. Note the map on the right, and the arid land is shown indicating the amount of land that has the potential to degrade and become less capable of sustaining human resource. The darker this land is, the more arid it is and less likely it is to be good for human consumption. So I did a quick feedback loop. So this is a positive desertification feedback loop. First, there's a reduction in biomass and vegetation, which leads to more soil erosion and less groundwater. And that leads to climate in that area becoming drier and more arid, which leads to water scarcity, which furthers the process of reduction in biomass and vegetation. As stated before, but with this slide more focused on how the temperature changes will affect human population in regards to desertification. As the climate temperatures increase, water stress increases, which means plants start dying off or drying out and not being as productive and being able to yield as much as normal. And drought intensity increases, which leads to longer periods without precipitation, which aids in the process of desertification, leading to habitats degrading with less resources available. I have already mentioned this, but I want to stress the negative effects. Food insecurity due to desertification is prevalent in many countries, but especially in Africa and Asia, where 90% of the population who face major food insecurity due to desertification and land degradation live in developing countries. This habitat stress only increases food insecurity, and the population living in arid regions is projected to grow to 4 billion people by 2100, further pushing people into food insecurity, poverty, and using land to farm and raise livestock when there globally will be a decrease in usable land. The map on the right shows a few severely food insecure countries, and white countries have no data. The dark blue countries have lost the most land due to desertification when comparing it to other graphs presented in this slideshow. There's also a poverty feedback loop with desertification. So as rural poverty increases, there's an increase of people living in these areas in unsustainable land management, agriculture, and deforestation, which further increases the desertification and soil erosion, water table, and the water table decreases, and droughts increase, while there's a decrease in crop yield and pastoralism. So how does desertification hurt the U.S., America specifically? So most of the negative effects of desertification appear to only affect developing countries, and that is not true. While the U.S. has the least amount of concern globally of damage due to desertification, there are still serious concerns. There is a huge drought increase within the entire North American continent, harming land use for agriculture and tourism and biodiversity, decreasing native species in arid regions. Mexico, which suffers from having the greatest amount of desertification on the continent of North America, with being incredibly food insecure and overall a major decrease in vegetation, affects the food trade within the U.S. globally. But also globally, this slide takes a more Eurocentric approach. There is more dune migration, which means more sands, which decreases land usability for resources and increases soil erosion. So it decreases vegetation usage. There overall is less land for livestock grazing ranges, which leads to overgrazing, deforestation problems. Land degradation leads to many negative events as drought increase and as precipitation increase. Throughout the U.S., a real-life example is there have been more events which lead to land resources being unusable. There's been a huge increase in 2019 to 2020 of dust storms across the U.S., negatively affecting vegetations everywhere, which is an example of land degradation. Finally, the last part of the presentation deals with reducing desertification. The best way to do this is not to recover land, but preventing desertification in the first place. While strides need to be taken to limit climate change through reducing carbon emissions, the best way to prevent desertification is to invest in sustainable land management through increasing vegetation, proper irrigation systems, not allowing for overgrazing or overcultivation, reducing soil erosion, which will increase vegetation, and increasing native biodiversity. These methods are best done through education, especially in developing countries, on sustainable land practices, increasing the yield without increasing land area, fighting poverty and food insecurity so more people don't turn to overcultivation and unsustainable land practices, and reducing the exploitation of developing countries. By practicing these methods globally leads to a decrease in land degradation and thus a decrease in desertification, which hopefully will reduce the effects that climate change has on the environment, especially in regard to desertification. Thank you. Here are my resources. Well, picture resources are located under the picture used or near it too. Thank you.